Hello there, and welcome to Group 15 slide presentation. As you all know, we were given a task to investigate how digital signal processing works. And this is Group 15 members, and my name is Ahmad Shadan Hijri Obakar, and I'm going to present our project. So this is basically the introduction of our project. Okay, most of the signals encountered in science and engineering are analog in nature. The signals are functions of a continuous variable such as time or space and usually take on values in a continuous range. In such a case, we say that the signals has been processed directly in its analog form as illustrated in picture below. As you can see, the analog input signal going through analog signal processor and the analog output signal we produce. Alright, and we proceed to objectives. So there are three main objectives in our project. Number one is to analyze a voice or sound signal from at least three different sources. Two, to understand how the digital signal processing is achieved. And three, by using MATLAB as a digital signal processing. Alright, before we continue to the other part, we need to know and understand the differences between analog and digital signal. Okay, analog signal is a continuous wave that keeps on changing over a time period. An analog signal is also described by the amplitude, period, or frequency and phase. One of the example of analog signal is basically a human voice. Okay, next, digital signal. A digital signal is a discrete wave that carries information in binary form. A digital signal is described by bit rate and bit intervals. Okay, basically the digital signal is used for transmission in a computer, and it's called as a digital signal. Okay, for our project, we decided to analyze uh, the sounds that came out from three cars, which is Ford MIV 2018, Ford MIV 2015, and also Ford MIV 2008. And here is the sound of Ford MIV 2018. Okay, listen. Okay, this is the sound that came out from Ford MIV. And this one is from okay, this is the video showing how we collect the sounds from the car. Basically, we use an app from an iPhone called Voice Memos. So this is the video. Enjoy. Okay, the first thing when we record the sounds, we ram the car until the tachometer hit 4000 RPM, just like a constant variable for our project. Okay, after we record all the sounds from the cars, we need to save it, and then we need to import it to the MATLAB. By doing that, we can analyze more about the signals. Okay, after we import the file into the MATLAB, we need to write some coding, some codes. Later, I'm going to show you the codes, and this is the graph showing audio signal versus time. This is the graph showing the amplitude versus frequency. As you all can see that the sounds produced from MyV 2018 is uniform to the graph that produced from the MATLAB. And this is the codes for the MATLAB. And after that, we just need to repeat the same step for the other two sounds, which is this is for the MyV 2015, the signal the audio signal versus time graph, and this one is the amplitude versus frequency MyV 2015. Okay, this is the coding for the MATLAB for MyV 2015. Okay, this is the audio signal versus time for Prodwa MyV 2008, and this is the amplitude versus frequency, and also this is the coding. Okay, in this project, we have discovered some errors that happen, which is random errors and systematic errors. Okay, for random error, as the audio file is not from the same source, there may be inconsistency in the loudness. So this may be affect the frequency since the three files do not have the same degree of loudness. And for systematic error, because of the audio file is not recorded in the soundproof conditions, hence there may be some background noise. And we also use phone recorder as tool to record the audio, and it may not be accurate. Okay, in a nutshell, our project objectives were achieved, and MATLAB software can be used as a medium to process analog signals into digital signals. There are also types of analysis audio file that can be used, for example, Audacity and Skylab. Thus, this project, we have shown that the process of converting analog to digital output is possible and the result is relevant. Yeah, thank you so much.